This is the Interim presentation from Group 6, the analysis and redesign of a space heater. The portable space heater is used to emit heat for a small to medium-sized room when it is plugged into an electric outlet. The heater consists of a fan, motor, heating element, metal mounting frame, control PCB, plastic outer case, knobs, and a tip-over safety switch. Customers can adjust the heating output and fan power independently by turning the control knobs. The direction of airflow is also adjustable. If the heater is lifted off the ground or falls over, the emergency kill switch on the bottom will decompress and automatically turn the heater off. The primary customer would be elderly homeowners whose homes typically have more inefficient heating systems and larger spaces. The secondary customer would be young apartment renters due to apartments having cheaper heating systems and smaller spaces. The estimated annual production is 230,000 units.
The core function of our space heater is simple: heat the space. To do that, it must meet two key functional requirements. 1. Create heat by converting energy, and 2. Direct the heat by generating airflow and adjusting its direction, either by selecting an angle or physically moving the unit. Beyond heating, the product must also ensure safety and reliability. It should stop heating when tipped over and remain stable during use. It must offer convenience and portability to fit easily into users' lives. To stand out in the market, our heater includes features like easy temperature control, airflow control, expanded coverage by increasing airflow or heat, and enhanced aesthetics to appeal to customer preferences.
In the first assembly sequence fishbone diagram, we start with a subassembly of the back cover, PCB, and control knobs, followed by the subassembly of the heating element frame, support brackets, and heating element. This is followed by mounting the motor to the frame, then attaching the fan subassembly to the motor. Finally, we add the front cover and stand subassembly to complete the assembly. In the second sequence, the back cover assembly now includes the heating element frame and support brackets, followed by the fan motor subassembly. The control PCB and knob subassembly is then added along with the heating element. Finally, the front cover is added, then the stand subassembly is added to create the heater assembly. By comparing the assembly sequences, we can see the second sequence is preferred due to having a higher ranking and ease of locating parts, testing subassemblies, and assembling in parallel. In the functional component matrix, all of our components are assigned to at least one function from the past diagram. In addition, none of our functions have over 40% of the components assigned to it. Components such as the heating elements and the fan blades are assigned to functions relating to the production and distribution of the heat and airflow. Other components such as the control PCB and knobs are assigned to functions relating to the control of the heat and the airflow.
This bill of material exploded view illustrates the full assembly of our space heater design. Each numbered part corresponds to a unique component. We will see the detailed material, process, and cost breakdown of the bill of material on the next slide. On this slide, we have a detailed cost breakdown of our space heater assembly, where the total unit cost comes out to $32.13 based on the projected volume of 230,000 units and the labor rate of $30 an hour. The key cost drivers in this analysis are the fan motor at $10, the control PCB at $7, and the silicone rubber feet at $3. These three components alone make up to nearly 2/3 of the total cost. We also have various methods of manufacturing. For example, injection molding for our covers, fan connectors, knobs, and stand, and metal stamping for our metallic components like the fan blades and support brackets. This breakdown also helps us identify areas that we might target cost reduction. But comparing our cost of $32 to the average retail price of $60, we are around 54% of the retail price of an average space heater. On this slide, we have the quad chart of our space heater, where on the bottom right, we identify the fan motor, the control PCB, and the heating element as candidates that we can optimize. Though these are purchase parts, we can definitely look into the market for some competitive prices to further drive our costs down. And then on the top quadrants, we identify the screws, the control knobs, and the fan connector that we can definitely look into optimize them, as well as the feet of the fan that we can definitely incorporate into the stand.
Now let's look at the product family design. After comparing the fast diagram functions with our primary and secondary customer groups, we found that only select angle and increase heat need to defer. Secondary customers, young apartment renters, have smaller spaces and don't need these features. In contrast, our primary customers, older individuals with larger, outdated homes, benefit from both angle flexibility and higher heat output. We've designed two variable modules to support this: the heating element, which can include an additional coil for more heat, and the stand, which can be fixed or angle adjustable. Despite these differences, the heating element frame design remains the same, accommodating either one or two heating coils. Similarly, the mounting points for the stand are standardized, regardless of whether angle adjustment is included.
The first interface for the secondary product is the supporting bracket that connects the heating elements to both the fan motor and the back cover. The second version has only one heating element that connects in the exact same way to the rest of the assembly as the primary version, which has two heating elements. The second interface for the secondary product are the covers which connect the supporting bracket to both the 4 feet and the safety switch. The secondary version has its mounting angle fixed, whereas the primary version's connections allow the end user to adjust the angle of the main heater assembly.
The standard assembly sequence for the heater leads to installing one of our variant components, the heating element, early in the process. This creates unnecessary variation for common components such as the fan blades. By shifting the element placement to the last step before loading the front cover of the heater, this increases the number of common components installed prior to the product variation formation. Thank you.